Okay, this is our final installment of Chapter 7. This is the supplemental section. I believe supplemental pages 47 to 52. Not much, but we'll go through it as fast as we can. About El Nino, tornadoes, tropical cyclones. Now, a little fun fact here for this one, was it here? Oh yeah, okay. So, we talk in here a lot about the widening wealth gap in the United States and the world. Well, this just is crazy. The wealthiest 3 families in the world have more wealth than the poorest 48 nations of the world combined. And I believe the UN currently recognizes 194 nations, right? So you take those poorest 48 nations, and the 3 wealthiest families in the world have more wealth than the 48 poorest nations. That's crazy. That's crazy! All right, here we go. So, we already know about weather. Short-term atmospheric conditions, experience blah, 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 yeah, blah, blah. Okay, so what we need to know, the temperature, or the word that you guys defined, I believe, was front. Boundary between 2 air masses with different temperatures and densities, right? Cold air is going to have a higher density. Warm air has a lower density. Okay, we got this. We got this. So fronts, warm, moist air rises over cold, dense air. So we've got this cold, dense air here, and this warm air is coming over it, right? Because since it's more dense, it's going to be pushed over it. It tends to happen slowly and gradually. So because of that, as this warm air rises and it becomes colder, right? When it gets into the higher troposphere, right? That water in it starts to condense, and you start to get these clouds, and these clouds just spread and cover the whole sky, right? And then all of a sudden it rains for days and days and days on end, like we just had here in Florida. That's because of this warm front that was moving over, okay? Now, so this leads to rain over long periods of time, dreary conditions. Over here, a cold front, when a cold front moves through, because it's more dense, and it's moving, they usually move quicker, they're just like pounding their way through this warm air front, So what happens is it takes that warm air at the bottom and it throws it up high into the troposphere very, very quickly. And again, as that warm air gets higher, the moisture in it condenses, forms these clouds very, very fast. That's where you get those big thunder clouds that form very abruptly, and then it drops rain. But these rainstorms usually last for minutes to maybe an hour, right? And then it's clear skies after that. That's when a cold front is moving in. And then you get that nice cool air behind it. Jet streams. Okay, so hurricane force winds near the top of the troposphere. There's a polar jet and there's a subtropical jet. As air gets to the top of the troposphere, it's very cold, right? Now, as you start to move into the stratosphere, which is very, very important, is located in the stratosphere. Think about it for a second. Hopefully you said the ozone layer, and if you did, you would be correct. Now the ozone layer, the ozone, traps the UV light, right? And in doing so, it also traps on to some infrared energy as well, and it starts to get warm. So when you move from the troposphere to the stratosphere, it starts to get hotter. So there is this big gradient in temperature differences between those 2 parts of our atmosphere. So there's a point where they don't mix because the temperature differences are so great. They don't want to mix together. They hit each other and they stay separate, all right? And it has to do partially also with the Coriolis effect, which gets it spinning. We can get these air currents moving very quickly at the top of the troposphere, and they might end up moving at 100 miles per hour, very, very quick. Atmospheric pressure, greater near the Earth's surface, of course. Air masses with high pressure are known as a high. Air masses with low pressure are known as a low. Okay. Global weather patterns shift every few years, and we're going to discuss that in talking about El Nino. So, El Nino disrupts normal weather patterns. We're actually beginning an El Nino weather pattern right now. Now, for much of the world, it's not good. If you're a fisherman, it's not good. But if you live in Florida, El Nino is usually well received because that change in pressure keeps the hurricanes from coming towards us. As they come towards us, this pressure system caused by El Nino forces them away. So we should have a pretty weak hurricane season this year because it's going to be an El Nino season. So typically what happens is there is this trade wind, right? A northeast trade wind that's blowing west, and it comes across the Pacific Ocean. And usually this wind, believe it or not, is blowing so strong that if you look at the ocean levels on the east coast, I apologize, on the west coast of the United States, where this wind is starting, and on the east coast of Asia and Japan, the ocean levels are 6 feet lower here than they are here off the coast of Asia, because all that wind is blowing this water this way. Isn't that crazy? 6 feet difference. As this air moves here and starts to rise, it drops water here on the east coast of Asia, which they need, and that's part of their normal climate, and they become dependent on it. Well, so every once in a while, every few years, this weather pattern, this system breaks down. These westward moving winds, they just stop blowing. And I had a climatologist in my class giving a speech a few years ago, and I asked them why this happens, and they're not exactly sure why it happens. So it can't really be explained properly yet. But what we do know is that it breaks down, and sometimes it actually reverses direction, and it starts blowing this water towards us on the west coast of the United States. And instead of having this single convection current here dropping the rain on the coast of Asia, we get these two cells, and the rain is dropping in the ocean. So we get dryness on Asia, all right? So let's see, what else? What happens is it depresses or stops upwellings. Upwellings is a movement of cold water from the bottom of the ocean up towards the surface, which are usually high in nutrients. And they bring food to the plankton that live close to the surface because they are dependent on sunlight. So they bring those nutrients to the plankton, which start the chain, the food chain in the ocean, and that keeps things going, and that's what feeds the fish, and that feeds the bigger fish, and so on and so forth. Well, when El Nino happens and this system breaks down, there's usually a lot of fish kills, low fish catches, so people in the fishing industry suffer during an El Nino season. Lack of upwelling decreases nutrients brought to the coast, lowering the primary productivity of the area and lowering the fish catch. So in El Nino season, if you can see, remember we said that a lot of that rain would drop here on the coast of Asia and even here in these islands and in Australia. So these areas experience droughts when they typically get some good rain in these locations. La Nina is the opposite. It strengthens that northeast trade wind blowing across the ocean and actually increases the upwelling. That's pretty much all you have to know about La Nina. It's the opposite of the El Nino. Okay, tornadoes. So tornadoes actually exist in the Midwest United States because we've got two things going on. We've got cold air coming down from Canada. We've got warm air coming up from Mexico. Whenever there are high discrepancies in temperature, something's going to happen. Just like the jet streams, right? The air that's at the top of the troposphere meeting the warm stratosphere that creates that jet stream. Well, when you have these two different temperatures of air fronts moving together, cold from Canada, warm from Mexico, well, they hit each other, right? And that warm air is shoved very, very quickly and violently up into the air. Now, as it starts going skyward, all you need is a wind current moving in an opposite direction to hit it, and think of it like a top, and cause it to spin. And as that happens, you start getting that circular movement, right? Which is going to suck more air up, and then when it cools down, it's going to suck the cool air down through the center, and you get this spiraling effect, which then creates the tornado. So take a minute, you can pause it here if you need to look at it longer, so now I was just standing in front of the words. Hurricanes. Okay, so here's some things you need to know about hurricanes. Okay, the low pressure system is over the water. It happens in tropical waters because it needs to be warm. So it's going to happen near the equator, and that's where these things form. So water temperature has to be roughly 80 degrees, okay? And it's a low pressure system. And the Coriolis effect determines the spin of the cyclone. Now, when we first looked at the Coriolis effect, I said later on I'm going to tell you to call it the Coriolis force. And this is when I want you to call it the Coriolis force. Because Coriolis force is very, very weak. But when applied to something very large...
Good afternoon, students, teachers, and staff. May I have your attention, please, for the afternoon announcements. Just a reminder that the next
It can
meeting
move
regarding
these things in different cycles. Northern hemisphere, counterclockwise, southern hemisphere, it moves it and spins it clockwise.
5:45 in the
Okay?
Media Center.
Have a great day.
Your NHS meeting will be this today in the cafeteria.